Okay, Darren Apstead, Chairman of the Collision Avoidance Committee with SLB. This is going to be a really short presentation because we really didn't have a meeting yesterday. We had one presentation. This was the agenda that we're going to subsequently now have as a virtual meeting. I'm going to give a couple dates in the next couple weeks. These are the things I came up that we want to check on the progress of our probability collision, who's implemented things, have they gotten any results back, how is it working, any test cases. We have some new updates on collision avoidance test profiles. We have some new ones that have been proposed for testing certain profiles that are being drilled that the current ones aren't adequately testing. We want to see, this is kind of a whole checkup, if you can see the profiles of how sidetrack implementation. We gave a couple options. Are they both working? We have Rev 5, which a large portion of it, we got most of the terms came from this breakout of the reference terms so that we could do the relative uncertainty correlations. I don't know that we have a lot of progress on that and seeing if people are working on it or we're kind of ignoring it. Documentation, kind of Phil mentioned some of we need to get better documentation, be able to find it on the website. And we have another list from previous that we have there's a lot of little tasks, little objects to go through. We saved our one bit of time for Keith Kenny to give a presentation. He gave a presentation on their automated anti-collision monitoring system and how it's gathering data and disseminating the results and any warnings to people, which is quite interesting. Obviously, it was appropriate for the collision avoidance, but it was also appropriate for these other systems that Phil showed for QCing, that you need to have good data going into these systems. And I included this. This was the abstract that Keith sent, and that's just because this presentation will go in there. And we're going to post his presentation online also. So you can read the abstract, and if you're interested, you then go get the presentation. Obviously not as good as seeing the presentation. These were the agenda items, and we're going to hold a virtual meeting. I normally would send out the invite to the email list that people that have been interested in the collision avoidance. If you don't think you're on there, Georgi put the new form on that Phil showed for the website to how to contact. Send me a message. I'll make sure you're on the list. Make sure you get the invite. You'll be involved in that way and find out what we do and all the details of these other items. That's it. One thing to add is that's an agenda. If you are having problems that you think we need to address that haven't been addressed, send us some feedback, especially because we have a lot of these changes that can have challenges of implementation, and as a group we can share some of the details, and so people don't necessarily need to sit and struggle all on their own. So send in other issues if needed.
All right, thank you. Any questions for Darren? All right, Mark.
Thanks. Hi again, everybody. I'm Mark from HP. I will say we got a lot done in our meeting. So sorry, Darren, we did take up some of your time, but I would like to think it was in the spirit of progress, which I want to alert the group. We are going to make an effort to break with error model tradition and actually try to move quickly on a couple of projects. And so I'm going to try to give you an update on a few things. And if you are interested or want to be involved, my email is here. Please contact me and please do it soon. So for some meeting highlights, we had about 50 people in person and 25 online. So a rather large group. It was so large, Carol attended, potentially her first error model subcommittee meeting because the education subcommittee meeting was at a slightly different time. But the three main things we discussed we're trying to push the rotating 6-axis magnetic survey error model across the finish line, and then review a guidance document that we wish to release with that, or shortly after that release. And then also an update from Keith Ricky's brother Kyle on a format for exchanging error models that ostensibly came out of a request from the OSDU, but we think might also actually be what we want to do in the future as a committee for things like version control and updating the tool codes. So at this point, with the rotating 6-axis error model, we believe that we have gotten past any technical objections. Some of the final remaining things caused us to add one additional term, or technically split an existing term into 2 terms. And at this point, all of the intent and what is captured is what we agree it should be. We are going to make some final logistics, bookkeeping, spelling fixes type adjustments, but otherwise we are going to consider this model ready for a version 1 release. One interesting point that came up as we were discussing this, when this depth shift compensation term was split into 2 components related to how the singularity errors would correlate or not correlate, is we realized that there is an implied property with some of our error model terms that, because it's a relatively small group of folks who are actually implementing them, it never got documented this way, but it probably would be good to document. And that is the fact that there are a number of terms in the error model that are implicitly paired. So the misalignment terms we talked about earlier, misalignments 1 and 2 are implicitly paired, 3 and 4 are implicitly paired. Similarly, these depth shift terms, like there's never a reason you would make an error model with only one of them, is sort of the idea. But the other important part of the handling is that when you do the singularity handling, if one of the 2 terms is in a singularity, you need a special calculation for both, even if one of the terms is technically calculatable. And that would also be true for these legacy terms, so we have an action to consider getting that updated in terms of documentation. Also, when discussing things that walking through this error model has taught us about our legacy generic error models, as we started to review a guidance document around what are the assumptions of that tool code, how is it supposed to be used, kind of like a quick user's guide, we realized that should also probably exist for the existing generic error models, because there's a lot of assumptions, there's a lot of things implied that are not necessarily obvious. And generally with our documentation, either it is sparse or incredibly deep. And so finding something that is in the like 1 to 2 page gets you 80% of the way there as a user, we think is something that could be done for a lot of our existing tool codes. I put together a draft of this guidance document. I distributed it to the committee prior to the meeting for review. I'm going to try to get a round of feedback. I am intentionally not publishing it on the website for review because I don't want this draft to somehow get conflated with an official document we're going to make later. If anyone would like to review it and provide feedback, please let me know. I'm happy to share it. I just don't want it getting misconstrued as something official as opposed to something we're considering. And then the final item is the OSDU collaboration. So there is a GitHub where updates to this will be provided, and where we would like to, in the future, host a lot of versions documentation for the error models. This is something that, again, is going to move quite quick. There's going to be a JSON format and a schema defined for how we can communicate and validate the existing generic error models in the JSON. And then this is also going to be the basis for some extensions we want to do to the error model. But because the OSDU would like this soon, we are going to have something released before the next meeting. So if you would like to review this. If you have strong opinions on how we should be sharing error models in JSON, please check out the GitHub. Please review the JSON schema. Please provide feedback soon, because within the next month or two, we are going to try and finalize. This is the first one we want to do that allows you to exchange the existing generic error models. It will be updated as we go forward. It is not going to be fixed by any means, but if you don't provide feedback on what you think needs to be in there right now, it will be version 2, not version 1. Because we do want to move pretty quickly on this. We're working on getting an agreement signed with OSDU. That's what I've got for our meeting. I would be happy to take nice questions. Not any questions, but nice ones would be good. Yes.
Obviously, the comment is to say that we've had a lot of kudos to you, and they like to move very, very quickly, so it's in our best interest to get us some of these. We don't want to do it.
And also for folks who have not been involved, another challenge, but I guess it's also a good thing for us, is that for OSDU, this is partly a box checking exercise. They want to say they can transfer tool codes. They are not in the tool code generation, positional covariance calculation business. They just want to be able to say, you can do this. And so they're willing to do more or less whatever we say is the right way to do it, as long as we give them something.
Thank you, Mark.
Thank you.